Welcome back to AI Unraveled, the strategic intelligence briefing for CTOs and VPs of engineering navigating the production frontier of AI. We're focusing today on the heavy metal sectors, energy and construction. These industries are sitting on petabytes of high-value data, yet they face the ultimate architectural challenge, fusing decades of legacy operational technology with a torrent of real-time, unstructured data coming from drones, thermal cameras, and robotic inspection systems. The data silos are not just annoying, they are a threat to operational safety and compliance. The question isn't whether Gemini or Copilot can reason. The question is, can your data architecture feed it the unified context it needs to deliver prescriptive, auditable answers? We're dedicating this episode to the three-stage blueprint for data fusion, proving how you can leverage edge preprocessing, vector databases, and RAG to break these silos and move from reactive maintenance to prescriptive, governed intelligence. Before we dive in, if you're building in the cloud and on the field, please hit that like and subscribe button now to ensure you receive our weekly technical deep dives. And if your company needs to move beyond generic content to deliver strategic thought leadership like this, tailored exactly to your industry vertical, whether it's fintech, health tech, or manufacturing, we specialize in crafting that message. Reach out to our strategy team for partnership opportunities at info@djamgaytech.com. Let's unravel the architecture of industrial AI. This is Industrial AI Unlocked.
If you look at some of the world's most foundational industries, energy, construction, manufacturing, you see this really stark contradiction. They are absolute giants when it comes to data generation. I mean, just think about it. Billions of IoT sensors, detailed engineering logs, drone scans covering every square meter.
Right. They are incredibly data-rich, but functionally, they're often data poor.
That's the paradox.
It really is,
Yeah.
the industrial data paradox.
Yeah.
And it's fundamentally a failure of access, not collection. The data's there, but it's locked up, locked inside organizational silos, technical silos.
And the scale of the waste is just huge.
Staggering. We've seen specific estimates, and they suggest something like 95.5%, an astonishing number of all data captured in engineering and construction actually goes unused.
Wow, 95%.
Yeah. It's basically trapped value. It ends up as digital landfill.
Okay, that's a shocking figure. And that really sets up our deep dive mission today. Understanding the new tech that's acting as this conversational catalyst.
Yeah.
To finally unlock that value.
We're talking generative AI platforms, specifically thinking about Google Gemini, Microsoft Copilot, as they start moving into these heavy industrial spaces.
But the idea isn't just that they write emails or something.
Not at all. The core thesis here is that these platforms are creating something different, a conversational semantic layer. Think of it like a simple natural language front end.
Easy to use.
Exactly. So easy, so democratizing, that it suddenly provides the kind of massive ROI needed to justify what is, let's be honest, complex, multi-year architectural work on the back end. You know, the work of true data fusion.
Ah, okay. So the friendly front end finally makes the difficult back end plumbing worth the cost and effort. It changes the math.
It totally changes the math. But crucially, you can't have one without the other. If you want that big payoff, that conversational ease, you absolutely need a three-part stack working together seamlessly.
Right. What are those three parts?
Okay, so first, you need that solid foundation. That's a federated data architecture, which most people now call a data mesh. That's number one.
Data mesh. Got it.
Second, you need what I'd call the non-negotiable safety control, a really robust grounding mechanism,
Right.
typically retrieval augmented generation, or RAG.
RAG for safety.
Okay. And then third, finally, you have that accessible natural language conversational interface on the front end, the part the user actually talks to.
Makes sense. Mesh, RG interface. But maybe before we jump into the solution, we should really dig into the problem first. Just how crippling are these silos?
We absolutely have to, because again, this isn't just about needing a software update. It's often deeply structural and sometimes cultural. Let's take the energy sector first.
Yeah.
They're just defined by this intractable IT-OT divide.
Okay, let's break that down. IT is information technology.
Right. IT manages the business side of things, your ERP systems, financials, HR databases, supply chain stuff, you know, the top floor perspective.
OT.
OT is operational technology. This manages and controls the physical world. This is the shop floor. SCADA systems, controllers for machinery, vibration sensors, pipeline monitors.
And that software is different.
Very different. Often proprietary, highly specialized, and this is key, frequently air-gapped, meaning disconnected from the main corporate network and the internet for physical safety and cybersecurity reasons. You don't want someone hacking a pipeline control system.
Okay, so that physical and digital separation creates this gap.
Precisely, a shop floor to top floor data vacuum. And that vacuum prevents real-time, holistic decision-making.
Can you give an example?
Sure. Imagine you're a maintenance supervisor. You're trying to optimize your team schedule, prevent failures. You need to ask what seems like a simple, critical question.
Okay.
I want to know, which of our high-pressure pumps are showing high vibration readings right now? Okay, that data is buried deep in some proprietary OT system.
Right, the air-gapped one.
Then you need to know, are those specific pumps still under warranty? Well, that's financial data, stuck in an IT system, maybe SAP or something.
Okay, different system.
And finally, and do we have spare parts for them available in the warehouse? That's inventory data, probably in another IT system, maybe the supply chain logistics platform.
Wow, so that one question hits 3 or 4 completely separate systems.
Exactly. And that simple fused query, the kind of query that could prevent a really costly, maybe even catastrophic equipment failure, it's traditionally been almost impossible to answer quickly. Those OT and IT systems, they just don't speak the same language. They don't live on the same network.
Okay, that paints a clear picture for energy. What about construction? You said their silos are different.
Yeah, in construction, the problem isn't so much technical or physical separation like IT/OT. It's more temporal and contractual.
Temporal, meaning related to time.
Exactly. The data fragmentation happens because the project itself gets handed off, like a baton in a relay race, through different phases in different companies.
Okay, like from the architect.
Right. The data starts with the architect, maybe in some specialized design software. Then it goes to the structural engineer, who updates the models in their software. Then to the general contractor, who's using field tracking apps on tablets.
And maybe subcontractors using their own apps?
Precisely.
Yeah.
And eventually, maybe, to the facility management team after the building is complete. At each handoff, knowledge gets lost. It gets lost because of software discontinuity, the different tools don't talk to each other smoothly, and it gets lost because the teams themselves change.
So you start with maybe these complex BIM models, building information models.
Yep. Then you move data into maybe a common data environment, a CDE, which is supposed to be the central hub.
Supposed to be.
Exactly. And then you've got all this data being captured out in the field using various custom apps or platforms.
And you mentioned that sometimes the CDE itself, the thing meant to unify everything, actually becomes another silo. How does that happen?
It happens all the time on big projects because different major subcontractors might be contractually obligated to use different CDE platforms. So instead of one single source of truth, the project data is actually fragmented across, say, 3 or 4 proprietary cloud CDEs.
Oof. So even the solution becomes part of the problem.
It can, yeah. That loss of continuity, that fragmentation is a massive driver of inefficiency, mistakes, and risk in construction.
Oh, okay. So we have these 2 huge critical industries practically drowning in data, but unable to ask even the simplest cross-silo question easily. That brings us neatly to part 2, the architectural solution that AI is finally making profitable.
Right, because historically companies tried to fix this. The big buzzword for a while was the data lake.
The data lake, I remember that. Shovel everything into one giant pool.
That was the idea. Try to dump all the data, IT, OT, drone logs, spreadsheets, everything, into one centralized monolithic system, but they mostly failed, often spectacularly.
Why? If the goal was unification, why did the data lake approach stumble?
Well, they often became data swamps. They were just too complex, too messy. The only people who could really navigate them or get value out of them were highly specialized data scientists who understood the obscure internal structures, the data cleaning protocols.
So not accessible to the average engineer or manager.
Not at all. And there was another big problem. No real accountability for data quality. The people who actually generated the data, the domain experts on the drilling team, the surveyors on the construction site, they weren't responsible for maintaining the quality of the data once it landed in the central lake.
So the people who knew if the data was right weren't in charge of it anymore.
Exactly. So you ended up with poor access, often questionable data quality, and therefore pretty poor ROI on these massive data lake investments.
Okay, and this is where generative AI comes in and flips the script.
This is the unlock moment.
Yeah.
Because Gen AI, specifically the conversational interface part, solves what you could call the last mile problem of data access.
The last...
Yeah. It makes accessing complex, fused data dead simple. You just use natural language. If I, as a site supervisor, can just ask a question in plain English, like I'd ask a colleague.
Instead of needing to know SQL or Python or navigate 5 different dashboards.
Right. That act of democratizing access suddenly makes the huge investment required in the underlying data architecture actually worthwhile.
The economic calculus shifts.
Totally. It shifts from how much does it cost us to build this complex data mesh, which is a big number, to, wow, how much money do we save and how much value do we create when basically every employee can instantly access real-time fused insights just by asking. The potential ROI becomes enormous.
But, okay, even with the conversational front end making it worthwhile, fusing that digital and physical data, you called it the as-built versus the as-is, that still sounds like a massive technical challenge.
Oh, yes. It's probably the biggest engineering hurdle right now.
How do you actually feed, say, unstructured field data like LiDAR point clouds from a drone or maybe logs from a spot robot alongside raw, like, time series numbers from IoT sensors, temperature, vibration into a large language model that's fundamentally built for text?
Yeah, LLMs are amazing text processors, right?
Yeah.
But they're generally terrible at interpreting complex, real-time numerical signals directly. Things like vibration frequency spikes or pressure decay curves, you have to somehow translate the messy, complex industrial world into a language the AI can actually understand.
Okay, here's where it gets really interesting for me. How did they do that translation? What are the techniques?
Well, the most practical workaround being used widely today is actually a pretty ingenious engineering hack. It's called visual prompting.
Visual or prompting, okay.
So instead of trying to wrestle the raw numerical time series data into some kind of text format that the LLM might understand, it's really hard.
Yeah.
An intermediary system visualizes the data first. It generates, say, a time series chart or maybe a heat map or some kind of graph on the fly.
It makes a picture of the numbers.
Exactly. And then the multimodal LLM one that can process images as well as text, like Gemini or GPT-4, with vision, uses its vision capabilities to read and interpret the chart, just like a human expert would.
Whoa, okay, so the LLM isn't actually solving the complex industrial physics or the signal processing problem itself.
Nope.
It's just looking at the picture, the trend line on the graph, and saying, that spike looks like an anomaly, or that pattern looks like the ones that came before the last failure.
You got it. It's using its powerful visual acuity to spot the pattern or the anomaly in the visualization. It's a really brilliant way to bypass the immense complexity of needing the LLM to understand things like, say, fluid dynamics or spectral analysis directly.
That is clever. Okay, what about deeper fusion, like combining totally different types of data?
Right. For that deeper cross-modal fusion, the more advanced method involves contrastive learning. This is where you explicitly train the AI to understand the semantic relationships between different kinds of sensory input.
So linking different data types that mean the same thing.
Precisely. For example, during training, you might show the model a drone image that clearly shows rust on a storage tank.
Okay.
And you pair that image with a text snippet from an inspection log that says pipeline corrosion report. And maybe also pair it with sensor data showing a corresponding pressure drop from that same pipeline segment around the same time.
So the model learns that the visual rust, the text report, and the numerical pressure drop are all connected. They all point to the same underlying physical issue.
Exactly. The model learns that these three distinct data types are semantically related to the same physical phenomenon, corrosion leading to a potential leak. That's the kind of sophisticated cross-modal reasoning you need for true industrial diagnosis and prediction.
Okay, that makes sense. But all of this sophisticated translation and fusion, it needs a really robust foundation to sit on, right? You mentioned the data mesh earlier. Why is that the preferred foundation now? Why not just, clean up the old data lake?
Because the data mesh isn't just a technical fix. It fundamentally flips the operational model for data management. It's a paradigm shift.
How so?
It shifts control and ownership away from that centralized bottleneck team, the data engineers or data scientists managing the lake, and pushes it out to a decentralized model based on domain ownership.
Domain ownership, meaning the teams that actually create and understand the data.
Precisely. So instead of just throwing raw data over the wall into a central lake and hoping someone else cleans it and makes sense of it.
Which often didn't happen.
Right. Now, the teams that understand the data best, say the drilling operations team or the project controls team in construction or the maintenance team, they become responsible for curating, cleaning, and serving their own data as a usable product to the rest of the enterprise.
So the drilling ops team owns, cleans, and maintains the drilling data product. They guarantee its quality, they document it, they make it discoverable.
Exactly. Because now, if the rest of the company is relying on their data product for analytics or AI applications, the accountability rests squarely with the domain experts who know that data inside and out.
That makes a lot of sense. It solves the quality problem, the governance problem, the accountability problem, things that really paralyzed those old centralized data lake systems. The data becomes a trustworthy product.
That's the core idea. Data as a product. Discoverable, addressable, trustworthy, and secure.
Okay, so the data mesh solves the data quality and trust problem. But wait, by unifying access to all these critical systems under one conceptual roof, doesn't it introduce a massive new risk? If we put a creative, sometimes unpredictable LLM on top of this beautiful unified data foundation, what happens when it hallucinates?
Ah, yes. The H word.
What happens when it confidently tells an operator to turn off the wrong high-pressure pump? Or suggests modifying a structural beam based on a misinterpretation?
This is absolutely critical. The safety conversation is non-negotiable in the industrial context. An LLM hallucination here isn't just inconvenient misinformation like you might get from a web search.
No.
It carries the potential for real physical harm, significant environmental damage, or even catastrophic asset failure. The stakes are just profoundly higher.
So this is where AgReg comes in. Retrieval augmented generation isn't just a fancy feature for better answers. It's the primary safety control.
It is the mandatory bridge. You absolutely need a RAG, or a similar verifiable grounding mechanism. RAG connects that powerful, potentially creative LLM to the verifiable, proprietary, high-quality data sitting in your data mesh.
How does it work exactly? How does RAG force that verification?
It's a pretty strict multi-step process. First, when a user asks a question, the RAG system doesn't just pass the question to the LLM. It first retrieves only the relevant verified data products from maybe the official safety manual or the latest engineering specifications or a real-time sensor alert feed.
Okay, finds the ground truth first.
Finds the ground truth. Second, it takes only that retrieved context and uses it to augment the original prompt being sent to the LLM. It essentially says to the LLM, answer this question, but base your answer only on the following verified information I'm giving you.
It limits the LLM's input to just the trusted data.
Exactly. And third, the LLM then generates an answer, but because it was constrained by that verified context, the answer should be factual and, crucially, auditable or traceable back to the specific source data product it came from.
That traceability sounds key. You can see why the AI gave that answer. That must be essential for building trust, especially when you're dealing with physical assets.
Absolutely essential. What other guardrails do companies put in place? Because the RAG is great, but maybe not foolproof.
Good question. Several other mitigation strategies are pretty much standard practice now. One critical technical control is setting the LLM's temperature parameter very low. Temperature? What's that?
Temperature controls the randomness or creativity of the LLM's output. A high temperature encourages more diverse creative answers. For industrial use, you crank it way down close to zero, maybe 0.1 to 0.4.
So you're basically telling the LLM, don't be creative, don't take risks, just give me the most probable deterministic answer based on the context.
You got it. You trade that potentially harmful creativity for certainty and predictability.
Makes sense.
Well, now, second, arguably most important safeguard is mandating human in the loop, or HITL, for certain types of outputs.
HITL, human oversight.
Yes. The rule is generally any output from the AI that recommends or suggests a physical action, shutting down a machine, adjusting a setting, initiating a specific repair protocol must be reviewed, verified, and ultimately executed by a qualified, credentialed human operator. The AI can suggest or recommend, but the human makes the final call and performs the action.
Okay, AI suggests, human executes. That feels like a sensible boundary. And finally, I guess governance means the LLM can't just know everything or talk to anyone. It needs permissions too.
Oh, absolutely. That's the final piece of the safety puzzle. The LLM itself must be treated as a permissioned entity within your IT infrastructure. It has to adhere strictly to the principle of least privilege.
Least privilege, only access what it absolutely needs.
Exactly. This is typically governed by granular, role-based access control, or RBAC, tied into your existing enterprise identity management systems. This is what proves security and compliance, especially to regulators.
Can we walk through an example? Let's use your scenario. A user queries the system about the Curl Lake pipeline status. How does RBAC change the answer?
Okay, perfect. Let's say the user making the query is a field operator out on site. They need immediate actionable information, but maybe not the deep predictive analytics. Their security profile reflects that.
So what do they see?
The RG system searches all the relevant data products in the mesh sensor data, maintenance logs, drone scans. But the final response presented to the operator is filtered by their RBAC profile. They might get something focused and low risk like pipeline pressure is nominal, vibration analysis is stable, your next scheduled visual inspection is at 4 p.m.
Actionable, simple, relevant to their role.
Exactly. Now let's say the same query, Curl Lake pipeline status, is made by the operations manager back in the control center. They have a different role, higher clearance. They need predictive insights for planning and resource allocation.
So they get a different answer.
Completely different, much richer. The manager, with higher clearance, might receive. Pressure is nominal. The latest drone thermal scan shows no immediate anomalies. However, our AI-driven sensor analysis, fusing historical vibration data, predicts a 15% probability of a related pump failure within the next 72 hours. A proactive maintenance window is recommended for Tuesday morning.
Wow. That's the fused predictive insight that delivers the huge ROI you were talking about. Same data foundation, different permission to view.
Precisely. And just to complete the picture, what if the user asking is an external contractor working on a specific, unrelated part of the site? They have very limited clearance.
What do they get? Access denied?
Pretty much. They'd likely receive a secure, compliant, and uninformative response like, I do not have access to real-time operational information for that specific asset, or simply access denied. The AI uses all the data to try and generate the best answer, but the final RBAC filter ensures the user only sees what they are authorized and contractually permitted to see.
That RBAC filtering is critical. It maintains security, protects sensitive commercial information, ensures regulatory compliance. It's like the essential license to operate for using AI in these high-stakes industrial environments.
Couldn't have said it better myself.
Okay, this is fascinating conceptually. Let's try and bring this theory to life now with a couple of real-world case studies. Where is this actually happening? Let's start with Imperial Oil in the energy sector.
Okay, yeah, Imperial Oil, especially their operations in challenging areas like Cold Lake in Canada, is a really interesting example of this IT-OT convergence being actively facilitated by Gen AI. They were dealing with incredibly complex new data streams that desperately needed fusion.
New data streams? Like what?
Well, things like robotics data coming from their Boston Dynamics Spot robots doing automated inspections in hazardous areas, highly specialized drone data. They even use things called robird drones, which look like birds of prey, specifically for autonomous wildlife deterrence around tailings ponds. That's unique data.
Wow, robot dogs and robot birds.
Yeah. Plus, vast networks of traditional AI-powered sensors and increasingly sophisticated digital twins virtual replicas used to simulate and optimize things like bitumen extraction processes.
So all these new technologies were fantastic, but they were inadvertently creating new, high-volume, highly dynamic data silos that their traditional IT systems just couldn't keep up with or correlate quickly enough.
That's exactly the problem they faced. The old way, if an engineer suspected a problem with a specific pump, might involve manually pulling up 4 or 5 different dashboards, trying to visually correlate sensor trends with maybe a maintenance log entry and perhaps a recent inspection photo. It was slow, reactive.
And now, with this conversational layer built on top of their fused data mesh.
Now, according to their leadership, they can effectively chat with their own data. An operations person can just ask that complex fused query we talked about, tell me the overall asset health of pump 4B.
And the system goes off and does the correlation automatically.
Yes. The system, using RA, grounded in their data mesh, correlates that pump's real-time sensor anomalies, that's the OT data, with maybe the latest thermal imaging from a drone flyover that's a field beta product, and perhaps cross-references it with Spot's robot inspection log from yesterday.
What's the tangible benefit? What's the value they get from that unified answer?
The primary value reported is a significant reduction in unplanned downtime. Instead of discovering a potential failure only when it's already well underway, maybe hours or days after it started degrading,
Right.
they can achieve true predictive maintenance, correlating a minor, maybe ambiguous sensor spike today with a subtle visual sign of wear spotted by a robot yesterday allows the operations manager to proactively initiate maintenance before a costly failure occurs.
And the savings.
They've indicated potential reductions in downtime costs of anywhere from 20% to 30% on some of their critical assets. That's huge. It fundamentally moves the organization from constantly reacting to fires to proactively preventing them. That's predictive operations in action.
That is a massive return on investment, essentially unlocked by just being able to intelligently unify 4 or 5 previously separate pieces of information. Okay, fantastic example. Now let's switch gears to construction and look at Skanska. You mentioned they have a sophisticated federated AI strategy.
Yes. Skanska is an ideal example for a couple of reasons. First, they recognized early on the importance of that foundational layer. They invested heavily in building a mature data mesh first.
What kind of data did they unify in their mesh?
They focused on bringing together their core data domains, project management data, often residing in systems like Procore CDE, their critical as-built data, captured by their large internal drone network doing site scans, their original design data from BIM models, and also IoT sensor data from sites, which they managed through an internally built platform called Falcon. Those became their core, trusted data products.
Okay, solid foundation. Now, their AI strategy on top of that, you called it federated. What does that mean? They don't just use one big AI for everything?
Exactly. Their approach is fascinating because it's not reliant on a single, monolithic, all-knowing LLM. Instead, they use a carefully curated mix of proprietary AI tools, partner-provided AI, and public AI models. It's a true ecosystem.
How do they decide which tool to use for what?
They smartly match the AI tool to the risk level of the task. For the absolute highest risk domain site safety and regulatory compliance, they built their own proprietary RA tool. They call it the Safety Sidekick.
Safety Sidekick. I like it.
And crucially, this Safety Sidekick is grounded only in Skanska's Internal Environmental Health and Safety, EHS manual, and the relevant government standards like OSHA in the U.S. Nothing else.
Ah, so it cannot hallucinate answers about safety based on random internet data. It only knows the official rules.
Precisely. It ensures verifiable, reliable, non-hallucinated answers for potentially life-critical decisions. That high-stakes proprietary knowledge is kept in its own secure, locked box.
Brilliant separation. Okay, what about less critical tasks?
Then for more routine day-to-day project management tasks, they leverage partner AI. A good example is using something like Procore Copilot, which is designed specifically to query their CDE for things like retrieving specific documents, checking the status of an RFI, request for information, or summarizing meeting notes.
So using an AI that's already integrated with a key platform they use.
Right. And then finally, for lower stakes, more general tasks, they utilize public LLMs like Google Gemini. Things like doing market research on new sustainable materials, brainstorming ideas for project efficiencies, or maybe synthesizing publicly available information on recent building code changes.
Okay, so a site supervisor doesn't need to remember which database holds which piece of information. They just need to know the right tool for their question.
You got it. If they have a question about safety protocols, they ask the Safety Sidekick RRED agent. If they need to know the delivery status of the structural steel for Sector 4, they ask the Procore Copilot integrated with their project data.
It's the right tool with the right permissions for the right job, but all securely querying that unified data mesh foundation underneath.
That's the federated model in action, and it really proves that central insight we discussed. Generative AI's most immediate and powerful role in the industrial sector isn't necessarily as a creator of novel content, but as a powerful data interpreter and, critically, a user-friendly interface.
It's that semantic layer again, the thing that finally unlocks that 95% of trapped value you mentioned at the start.
Exactly.
Now, when companies are making those big platform decisions, maybe choosing between, say, the Google ecosystem with Gemini or the Microsoft ecosystem with Copilot, we stressed earlier that the choice isn't really about which base model is objectively smarter or has more parameters.
No, I really don't think that's the right way to look at it, especially in industry. It's almost purely an ecosystem decision. It should be based heavily on your existing infrastructure investments and where your data already lives.
So if you're already heavily invested in Microsoft Azure, use Microsoft 365 extensively, run your business on Teams.
Then Microsoft Copilot is almost certainly the more logical, integrated choice for you. Microsoft excels at embedding this AI capability directly into existing business processes and productivity workflows that your employees already use every day.
And conversely, if your organization is primarily on Google Cloud Platform, GCP,
then Google Gemini is likely the better fit. Google often excels, particularly with its multimodal capabilities, at that deep research, complex data analysis, and cross-modal reasoning we talked about earlier. which kind of explains why Skanska, for instance, chose to leverage Gemini specifically for those public research and analysis tasks.
Okay, so it's less about the AI model itself and more about the plumbing it connects to most easily.
Pretty much. Which AI talks best to your existing data and workflows? That's the key question.
So wrapping this up, what does all this mean for industrial leaders who are looking at this space and thinking about where to invest their time and capital moving forward? What's the key strategic takeaway?
I think the most critical strategic takeaway is this. Industrial leaders need to stop focusing so intensely on the question, which LLM should we buy or build? That's almost the last step.
Where should the focus be then?
The primary focus, the real investment, needs to be on building that robust, federated data mesh foundation first. And just as importantly, formally appointing and empowering those accountable data product owners within the business domains.
Get your data house in order before you invite the AI interpreter in.
Exactly. The AI, the conversational interface layer, is increasingly something you can license or plug in. But the trustworthy, high-quality, well-documented, fused data products that is the core, enduring strategic asset that provides the competitive advantage. The future isn't one single monolithic AI controlling everything.
What is it then?
It's going to be a fluid, federated ecosystem.
Yeah.
A mix of highly specialized proprietary RAG agents for critical tasks like Skanska's Safety Sidekick, integrated partner AI like Procore Copilot for platform-specific queries, and likely some use of powerful public models for general knowledge tasks. All of them securely and appropriately querying that unified data foundation.
A mix and match approach, governed by strong data ownership and security.
Oh, yeah.
Which leads us, I think, to our final provocative thought for you, our listeners, to maybe mull over. We talked quite a bit today about integrating sensor data, RAG systems, and the data mesh. Now, consider that RAG systems are also starting to be deeply integrated with another key industrial technology, the digital twin.
Right, the digital twin, that interactive 3D, often geometrically precise model that represents the hierarchy and state of physical assets on an industrial site.
So if you connect the RAG system, which understands documents and data, to the digital twin, which understands the physical asset structure, where does that lead?
Well, it suggests we're moving very quickly towards a future where industrial users won't just be asking questions about documents or logs or even sensor readings in isolation.
What will they be asking?
They'll likely be asking questions directly to the virtual representation of the physical assets themselves. You might not ask, what does the maintenance manual page 57 say about Pump 4B's lubrication schedule?
What would you ask instead?
You might just point your interface at the 3D model of Pump 4B in the digital twin and ask, much more directly, why are you vibrating abnormally, Pump 4B? Or what's your predicted remaining useful life based on your current operational state and maintenance history? Asking the asset itself. That's the direction this seems to be heading.
That concludes our deep dive into industrial AI Unlocked. The core takeaway for your strategy is clear. The LLM is only as effective as the unified data fabric you build beneath it. By prioritizing edge filtering for volume control and the vector database for contextual fusion, you create the necessary architecture for auditable, prescriptive AI outputs in critical industrial environments. Our conversation continues tomorrow when we shift focus to the legal and technical requirements for deploying synthetic data at scale. Essential listening for every compliance and data governance leader. Before you go, if this episode has provided valuable technical insights for your next sprint or strategic planning session, please take a moment to rate the show and hit that like and subscribe button. Your support helps us remain the most focused, high-signal podcast in enterprise AI. And a final note for our corporate partners. Are you seeking to establish authority and deliver clear technical value to your enterprise customers? If you're looking for a bespoke podcasting solution, a vertical briefing written and produced specifically for your niche, our team at Dissecting Tech is ready to partner with you. For information on creating a tailored thought leadership channel that speaks directly to VPs and CTOs in your industry, contact us today at info@dissectingtech.com. Thanks for tuning in to AI Unraveled. Until next time, keep building.